All right, I just want to take a moment to record the notes for discovering parts of an atom. This is the introduction to the atomic chapter or unit. Discusses kind of the origins of atomic theory and some of the components of an atom itself. So when we talk about early ideas of matter, one of the first things we talk about is the earlier philosophers who thought that all matter was made of only four elements: fire, water, air, and earth. Kind of like if you ever watch Avatar Airbender, they believe that everything in the world was created either of water, fire, wind, and earth, or variations of those elements. Because of the lack of scientific knowledge and scientific method, they weren't really able to test their theories to see what really matter was made out of. It wasn't until 400 BC when Democritus proposed that matter was made of these small, indivisible objects called atoms. Atomos actually means cannot be divided. So he thought if you broke material down, cut it in half and cut it in half, there would be a point where you couldn't divide it anymore. That part where you couldn't divide it and make it any smaller would be the atom. Although he proposed that different types of matter contains different types of atoms. So water was made of water atoms and iron was made of iron atoms as well. Not much later, Dalton came around. John Dalton, he proposed the atomic theory, which was based on careful observations and measurements of chemical reactions. So he could test his theories on atomic structure to see how they panned out. He thought, first of all, that atoms cannot be divided, created, or destroyed, which we still believe to this day. We can split certain atoms. We can combine atoms. But we really can't destroy or create matter. We can only shuffle it around. It's also stated that atoms of one element are different from atoms of other elements. So he thought that like carbon was different than methane, which was different than oxygen. Again, kind of building on Democritus' belief that different kind of elements had different kinds of atoms. We recognize that the atom is the smallest piece of an element that still represents the properties of that element. We first saw them in the early part of the 1900s using scanning tunneling microscopes. So it was our first time to actually see atoms. Up until this point, it was all based on scientific experiments and theory. Sorry about that. All right, so it was later on that Thomson came up with the part of the Thomson discovered the tested by using a cathode ray tube. It's an old tube used to find in TVs. But what he noticed was that when he charged a plate, you can actually see it in the picture there. That when he charged a plate, when it came close to the bar, it would actually move it. So there was a positive and negative reaction kind of happening when he moved the plate. So something had to be doing that. And what he thought that the atom is a positively charged sphere and that there are electrons throughout. And it was those positive negative charges that either attracted or pulled or pushed away an object. Now his model, again, it's kind of like almost like a chocolate chip cookie model because you have the electrons and the protons spread throughout the atom. Further testing by Rutherford, he was a student who performed an experiment where he shot particles at a piece of gold foil. And what he expected to do was for them just to pass right through the foil because they're so small. But what happened was every once in a while, a particle would bounce back or would hit and deflect. So there had to be something in the center of those atoms that they were hitting. So although most of the particles traveled through the foil, some bounced back to the side, some bounced straight back, what he determined was that there was a new atomic model and there was a big mass in the middle called the nucleus. And we had most of the mass and the positive charge was in the center of that atom, which still holds true today. The nucleus is where the protons and neutrons are located, and it's most of the mass of the atom, and it contains a positive charge because of the positive protons. The nucleus, again, is a small positively charged area in the center of the atom, and it contains protons and neutrons, but it is the mass of the atom. It's most of the mass of the atom. And the nucleus is the proton. Protons have a positive charge. An atomic particle has a positive charge. We'll talk more about protons tomorrow. But then the other part of the nucleus are the neutrons. James Chadwick was one of the colleagues of Rutherford who was doing experiments with the gold foil and the alpha particles. And what he discovered was the neutron, which is a neutral particle that's also in the nucleus of an atom. Neutral means it has no charge. It's not positive, it's not negative. It is just a neutral atom, a neutral subatomic particle, sorry. Further testing along the years, and Niels Bohr came along with his atomic model. The atomic model of Bohr proposed that electrons move in these circular orbits or energy levels around the nucleus. So here is our nucleus. We have these electrons, these smaller particles, negatively charged particles that go around the nucleus in these set orbits, also known as rings or shells or energy levels. There's a lot of different names for them. When energy was added to the atom, electrons could bounce between energy levels, and then when the energy was released, it would bounce back. So when we talk about chemical reactions later on, a lot of the release of energy, absorption of energy, is due to electrons going up a level or going down a level on the electron shells. Problem with Bohr's model is that electrons don't actually move in circular orbits. Electrons are really strange particles, almost no mass to them. There are certain theories that they actually blink in and out of existence periodically from time to time. So the circular orbit model of Bohr went away fairly quickly to be covered with a cloud model. So what that leaves us with is our current understanding, as woeful as it is, of the modern atomic model. In a modern atomic theory, electrons form an electron cloud, which is an electron where it's an area around the nucleus where you're likely to find an electron. You can't guarantee you're going to find an electron. One of the things you discover about electrons is you can know where they are, but you can't know where they're going. You can't predict. So what they called it was an electron cloud because it's this whole fuzzy area that at any point the electron could be in that cloud. The electron cloud is mostly empty space. Again, electrons have very little mass to them. So even the cloud itself has mostly empty space. Most of an atom is mostly empty space. And even below protons, neutrons, and electrons, there are even smaller particles that we're beginning to discover. But we know that protons and neutrons are actually made of smaller particles called quarks. There are 6 types of quarks. There's the up quark, down quark, strange, charm, top, and bottom quark. And all those composed to find, as you saw in the previous one, they form protons, neutrons, antiprotons, based on how many of each structure they have. So those are the notes on the lesson outline for Intro to Atomic Theory. Most of these things we will go over in greater depth as we move on to the specific parts of an atom, the protons, neutrons, and electrons. Hopefully that is helpful.